In this video, we will take a look at the concept of common tangents. When we have two circles like this, we can draw four common tangents to these two circles. There is a special case, particularly when the two circles are like this, we describe this case as two circles touching each other. When we have two circles touching each other, there is a point of contact. At this point of contact, we can draw a tangent which is common to both circles. By tangent perpendicular to radius, we should know that angle PXA is equal to 90 degrees, and similarly, angle PXB is also 90 degrees. Therefore, angle AXB is known to be 180 degrees. Therefore, it can be proven that AXB is actually a straight line, or we may say that the points A, X, and B are collinear. Based on this result, if the radii of the two circles are R1 and R2, then the length of AB can be found to be R1 plus R2. Later, when you see two circles touching each other, you can apply this result without any proof. There is another way for two circles to touch each other. It is like this. If two circles are touching each other in this way, we can still say that AX and B are collinear. But here, AB should be the difference between the two radii. To distinguish these two cases, for the first case, it is described as two circles touching each other externally, and then for the second case, the two circles are touching each other internally. Now let's take a look at this example. In this figure, PQ is a common tangent to the circles, and we need to find the length of PQ. First of all, we can construct C on AP such that BC is perpendicular to AP. And since we know that angle APQ and angle BQP are both 90 degrees because of tangent perpendicular to radius, we should know that PQBC is a rectangle, and therefore CP should be equal to BQ and CB should be equal to PQ. That means we can find the length of PQ by considering Pythagoras' theorem. For the length of AB, as mentioned previously, for two circles touching externally, the length of AB should be the sum of the two radii, so that is 20 meters. For AC, by our construction, it is equal to the difference between 16 and 4, so that is 12 meters. Now, by focusing on triangle ACB, we can apply Pythagoras' theorem and get that CB should be equal to 16 meters. And therefore, PQ is equal to CB, which is equal to 16 meters. To conclude, when we have two circles touching each other, the two centers and the point of contact must be collinear. For two circles touching externally, the distance between the centers is equal to the sum of their radii. And for two circles touching internally, the distance between the centers is equal to the difference between their radii.